So we are going to talk about how Parkinson's and Huntingdon's diseases come about owing to the various pathways being affected. So either the direct pathway or the indirect pathway will be affected. So here, let's go. So what we've got here in this picture, now this is both the direct and the indirect pathways on the same diagram. Again, it looks terrifying, it's not. Okay, so the outer loop here is the indirect pathway. So coming in from the cortex into the putamen, over to the globus pallidus externus, down to the subthalamic nucleus, back to the globus pallidus internus, over to the thalamus where it is telling it, hey, hold your horses, and then inhibitory messages are sent to the cortex. So we're looking at less movement, indirect pathway, less movement. Then the inner loop here is your direct pathway. So this is exciting the cortex, so getting in more movement. So we come from the cortex into the putamen of the lentiform nucleus, shooting over across to the globus pallidus internus, over to the thalamus, where we are encouraging excitatory neurotransmitters to go to the cortex, excitation, more movement. Okay, so that's the two pathways, and we have Parkinson's disease and Huntington's disease, and we're going to just talk a little bit about how they work, or how they affect this pathways. So you can see we've got the substantia nigra now, which is part of the basal ganglia. So first of all, we've got, in this diagram, we've got, what have we got? We've got dopamine releasing neurons. Yeah? So these release dopamine. So, your substantia nigra, one dopamine neuron, releasing neuron, affects the direct pathway. So this comes up here and affects the direct pathway. And this releases D1. Well, it doesn't release D1. This is called D1, sorry, which stimulates the direct pathway. So D1 stimulates the direct pathway. And then we've got D2. What does this do? This inhibits the indirect pathway. So this one comes here onto there, right? This is D2. So D2, inhibits the indirect pathway. Okay, so let's find another colour. So these, let's have a little. These will both facilitate more movement. Anyway, right. What does dopamine do? So dopamine is responsible for fine control of movement, of fine tuning. It fine tunes the direct and indirect pathway, so you've got smooth movement. Okay, so fine control, fine tuning, smooth movement. Smooth movement. Okay, so there we go, get the picture in. So if we have, let's find another colour, right? Okay, so Parkinson's disease affects the dopamine pathway itself. Okay, so this is Parkinson's here. It affects the dopamine pathway. So X equals Parkinson's. Okay, and if that affects the dopamine pathway, you have less dopaminergic neurons. So therefore, less global movements will occur. So Parkinson's is known as a hypokinetic disorder. Hypokinetic disorder. Okay, so there is less movement. Parkinson's is a hypokinetic disorder, and it affects this dopamine pathway. Huntingdons affects the indirect pathway. Okay, and let me just find a suitable colour. Oh, I don't know what colour to use. Oh, we'll use purple again. So many colours, such little time. No, actually, no, we won't use purple again. We'll use this green one. Oops. So, green. So, what was I? Huntingdons, right, affects this part here. That part of the indirect pathway. Okay. So write that there. Is Huntingdons. Huntingdons. Okay, so let's have a look. So if this is affecting this part of the indirect pathway, right? What is the indirect pathway doing? It's causing, or the idea of the indirect pathway is so that there is less movement sent to the cortex, yeah? So if you cut out this one here, and then you reduce the amount of, if you like, stimulation for that inhibitory movement to occur. So there's less inhibition. So initially in Huntington's, it affects here, and it doesn't work properly. It doesn't work great. It still works to some degree, but not great. Your indirect pathway is affected. Once the whole nerve is knackered, right? Once the whole nerve is knackered, then you effectively lose your indirect pathway. And all that is left is your direct pathway. And what does the direct pathway do? The direct pathway, boof, 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 is to excite the cortex. The thalamus is exciting the cortex, and you've got nothing to rein it in because your indirect pathways are gone. So therefore, Huntingdon's is a hyperkinetic disorder. Hyperkinetic disorder. Okay, and that is how Parkinson's and Huntingdon's come about in those indirect and direct pathways. So Parkinson's, less dopaminergic neurons, and then Huntington's, it affects the indirect pathway, so there's less inhibition and it becomes a hyperkinetic disorder. Also, which I forgot to mention earlier, substantia nigra, as you can see I've coloured it in black here. Substantia nigra means something big, something black, so it's a big black part of your brain. With Parkinson's, as you progressively get worse, you lose the blackness. So I think it's on a head CT or brain CT even, they can tell you've got Parkinson's by looking at the blackness of your substantia nigra. So there you go. And that is Parkinson's and Huntingdon's.